Hello, this is John from Computer Security CS4173, Section 995, summer of 2025. Today I'm going to go over my secure chat application, which is a project that we did that demonstrates encryption over an application so that we can send encrypted text messages and files. And first thing I'm going to show you is my environment and my seed VM. I have all my source in this directory here. I have some scripts that I can use to build and run the application. Right now I'm going to run two instances. I have a script that will build the source, run two instances, and create it. Before it runs them, it will create two working directories. And as you can see here, it is started two instances, one for Bob, one for Alice. Up here is the working directory for each, and there were some files in here on my previous run. It cleared those out, so we get a fresh instance each time. Okay, real quick, I'm just going to send a test message from Alice to Bob. Up here is the plain text. Here's the ciphertext. As you can see, Bob got the ciphertext and converted it into the plain text. And after that, I'm gonna send a file. So from Alice, I'm going to send an MP3. So I'll click send file, and here's my MP3. And here you can see it's much bigger ciphertext this time, a lot more bytes in it. And here is the file that Bob received. We received the ciphertext. We could tell what the file name was, so we just write the file and then write the encrypted bytes to it. I can't run the MP3 in my seed VMs for some reason, so I'll run it on my Windows host. Just so you can tell that it still works. Now I'm going to send a video file from Bob to Alice, so I'll select send file, and I have a sample video right here. Okay. So I just wanted to point out real quick that the ciphertext is super long on this video file, and it is not wrapping for some reason. It's all pasted on one line, but we do get the full ciphertext. And I can prove that by running this. This one I actually can run in Linux, the VLC player. And here's the video file. Okay, there's that. My application also supports different modes, so let me clear that long ciphertext. I'm going to switch them both to DES. Send. And one thing I wanted to point out real quick is if we send the same plain text twice, we're going to get different ciphertexts. So you can see that these are different, and I'll explain why that is when we look at the code. Let's see, is there anything else I need to say about this? I think that's it. The apps are started up with command line options, so they needed to know the username, who was going to host, and who was going to connect on what ports and IPs and all that. And they also have to be configured with the same passphrase, so they agree on the same phrase, and that is the root of how everything is encrypted. All right, so we're moving over to the source. This is the main of the application. The thing's built with Qt, which is just a GUI framework. It creates the windows. It allows me to have all those controls, the buttons and stuff. In the main, we parse those command line arguments, the host, the port, and the password, as well as the username. We parse all those out and hand them over to a new window. And the chat window is made with all those Qt controls. We set them up, we lay them out, and we set up event handlers for the various clicks and toggles. Also for when the TCP socket gets a new connection. Upon connect, it's going to set up another event for when it's ready to read the bytes that are coming over the stream when somebody sends a message. So when we send a message, we have a scheme here that tells us whether it's a file or a text. We add the username, the file name and extension, and then the encrypted data. So let's see, there is a function in here called send packet. We get this JSON object and encrypt it, and that happens right here. Let's see, excuse me, send packet right here. And we get the plain bytes from that message and call crypto.encrypt. This crypto object is a class that's in the source. I'll show you that next. But yeah, all we have to do is get the ciphertext from the crypto class, and we write that to the socket. And the other side is set up to know when a message is ready to read on the other side, and reads the stream like this, and calls crypto decrypt to get the plain text. And then here we're doing a little bit of parsing to tell whether it was a text message or a file. If it's a file, we just make that file and write the bytes to it. So that's how we're handling audio and video stuff. And let's see. The crypto class, the most important part of this whole thing, is created using that passphrase. The first thing it's going to do with that is hash it with SHA-256. This guarantees a hash of the same length no matter how big the key is. So that hash comes into play when we're making a key for the encryption. So depending on our mode, if it's DES, we're going to get 56 bytes, or 56 bits plus 8 parity bits, 8 bytes total. We're going to take the first 8 bytes of the hash, that's our key. And then if it's AES, we need 128 bits, 16 bytes, first 16 bytes of the hash. And this will change when you toggle the encryption mode. So when it comes time to decrypt, we're leveraging the OpenSSL libraries, and we use this for a lab. It was already set up on our VM, so I'm kind of familiar with it already. Here, the first thing we do is make a initializing vector, and that just creates random bytes. And this is why the ciphertext was different. Even though you can send the same plain text each time, you get a different ciphertext due to the initializing vector. Then we make an array for the ciphertext, and that thing is going to be the size of the initializing array or initializing vector, the plain text, and a single block size. Depending on what mode, this will be a different size. So then we have to set up the encryption context that takes the algorithm and our key and our initializing vector and places that into buffers in memory so it can read from it. Then the actual encryption is this EVP encrypt update. That is going to take the pointer at where to start writing the encrypted bytes. It's going to take the pointer of where the plain text starts and write it to this location, which was the cipher data plus the initializing vector size. That's going to give us an out length to determine whether we need extra padding or not, because the size has to be in a multiple of the block size for the algorithm. That happens with this encrypt final call. And then once we get the second out length size, we can resize the ciphertext to make sure it's a multiple of the block size. Decrypt is the same way. We need to select an algorithm based on our mode. Since that initializing vector was pre-pended, we can just grab it from the front. We're going to use that to decrypt with. And then we get the location where the encrypted bytes start. And same thing as the encrypt side, we got to initialize it with the key initializing vector. And then the decrypt function call is going to run the algorithm for us and read from the encrypted pointer right to the plain text pointer. Or again, we're going to pad and resize, and that's the plain text encryption. And I think that about covers it. It's not too complicated, but yeah, is there anything else I'm forgetting? Mentioned it was made with Qt using OpenSSL. Gave the demo, so I think that's about all I have to show off. Thank you for watching.